How's it going, geometry guys? As you can see, I'm making this video in an even different spot in my house. I'm doing this so I can stand further away from the screen because I'm going to be doing a lot of stuff with my arms to show you the different. I guess I don't really need to, but I like to stand. All right. I just realized my picture's in the way. Magic. That's magic right there. All right. So let's go through the different types of angle pairs. Oh. Whoa, I'm moving everywhere. I gotta get that out in front. Yep. Alright, so here we go. First thing we're going to talk about are adjacent angles. Alright? Adjacent means next to. If you're adjacent to something, you're next to it. So adjacent angles are two angles that share a vertex. One of those vertexes in the middle. Alright? So I don't really. Alright. So do you see how like angle 1 and 2 are adjacent? Because they actually share this. That's like they're holding hands, right? They're standing next to everyone, they're holding hands right in the middle. Alright? And 3 and 4 are also holding hands because they're adjacent. They like to be next to each other. Alright? So adjacent angles share a vertex. Vertical angles. Vertical angles make like a bow tie. Oh no, where'd my picture go? I'm everywhere, I keep moving. I don't know, I can't find a good spot to put my face. Maybe I should just take it out. The studies show that like it works better because as humans, I don't know. Alright, now vertical angles could also be called bow tie angles. I call them bow tie angles. Because when you make a bow tie, you want both sides to look equal, right? You don't want to look like a fool with mishmash bow ties. So vertical angles, they also always look like an X. Alright? And they're the angles that look at each other are equal. So the two from the side, and the two from the top and bottom. Okay, see that? I'll use my highlighter tool again. Like angle 1 and 2 are equal. And you can kind of look at it and see an angle, that's supposed to change color. Angle 3 and 4 are congruent, right? Bow tie angles, vertical angles. Vertical angles, the vertexes point at each other. Okay? Vertical vertex points, I don't know. Something here's got to click with you guys. Alright. Alright, next one we're going to look at complementary angles. Those are two angles that add up to 90 degrees. Now, you can see the example of 1 and 2, they're right next to each other. They're adjacent. They're adjacent complementary angles because they're next to each other. They share that one ray in the middle. But yet A and B, if you look over to the side, the 47, 43 are still complementary. They don't have to be next to each other. Do you guys know that 90-degree angle is also called a right angle? Right? Right. And that's why I use this little thing to help me remember. I compliment my wife to make things right. Complementary, right angles. Okay? And supplementary. Oh, you're missing an angle here. Oh, no, you aren't. So supplementary angles, supple bigger, supple makes, actually they make a straight line, 180 degrees. Supplementary angles are angles that add up to 180 degrees. It's a supplement. So like 3 and 4 make a straight line. Straight line is 180 degrees. 3 and 4 are supplementary angles. They're also called linear pair because they make a line. Right? Now, and B and C, so we're using, B and C are complementary or supplementary. They don't have to touch, but what's 137 plus 43? Why, it's 180. For example, if I know an angle is 60 degrees and I'm asked to find a supplement, well, its supplementary angle would be 120 because 120 plus 60 equals 180. A lot of times what you're going to do in problems on this is they're going to ask you an angle and its complement are x and 2x. So you do x plus 2x equals 90 because it's complement. If it's supplement, use 180. We'll do a few of these in class, all right, to help you guys through it before I give you guys your problems. Sound fair? Sure, it's the only deal I'm giving you guys. All right? All right, next page. All right, we're going to use this diagram and tell whether or not each statement is true. First one, AFE and CFD are vertical angles. So again, if you ever want to use colored pencils on your homework, go for it. I have to mark up stuff. So I'm looking at AFE, right? Just don't write in your book. Like, draw out and then highlight it. Then you do whatever you want. Don't write in your book. Right? You're not a book writer yet. So that's AFE and CFD. Let's take a look. It looks like a bow tie. They're formed by the same two lines intersecting. So I would say yes. All right. Next one. Are BFC and DFE supplementary? Supplementary, as we recall from learning 2 minutes ago, means 180 degrees. Well, these add up to 180 degrees, all right? So let's see here. We're looking at, what are we looking at? BFC. BFC is 28 degrees. And DFE. Well, 118 plus 28 is not 180. So I'm going to say a no dice. No. Don't add to 180 degrees. And last one. BFD and AFB are adjacent. All right. So BFD, 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 and AFB, AFB. Are those adjacent? Yes. They share BF, right? They share that ray. If you share a ray, then you are adjacent. They're next to each other. They're holding hands at BF. Because BF means best friends. Oh dear, that was awful. Alright. Some things to look at when we're looking at a diagram. I'm actually gonna, let me expand on this. Do it. Making it larger. Anyway. When you have a picture, there are some things you can assume by looking at it. Remember when you assume? Not good. Alright. So if you have a picture, you can tell they're adjacent. You can tell they're adjacent supplementary if they form a line. And you can tell if they're vertical. Now if it's not marked, you cannot always tell they're congruent if they're not marked. You can't tell it's a right angle unless it's marked. They'll put a little box there. And you cannot tell they're complementary unless it's marked as a right angle. All right? So let's take a look at this picture of my graph. Yeah. All right. Can we draw conclusions based on the information given to us? All right. Whoa, where are you? Stop. Stop doing that. Why doesn't anyone listen to me? TW equals WB. Well, if I look over here, TW, there's a line there, and WB, there's a little dash there. So, yes. Why? Because they're marked. They're marked. So, yeah, they are. Of course. Oh, but of course. Now, what about PW and WQ? It looks like it, but they're not marked. So, no. I can't just say it. They're not marked. How about TWQ is a right angle? Again, it's not marked. If I put that there, I could say, yes, it's a right angle. But because it's not marked, I have to say no. What about TV bisects PQ? Now remember, bisect means to cut in half, right? But I don't know if PW equals WQ. So I just don't know. It looks like it, but I don't know. So I gotta say no. Alright guys, 2 more slides to go. Next thing we're going to talk about is linear pair. A linear pair is a pair of angles that make a line. Linear means line, so hopefully it makes like that should click. So we have a postulate. If they form a linear pair, they're supplementary. Because what's the angle of the line? 180 degrees. So of course they're supplementary. Right? You can kind of look up here in the picture, this forms a line, and the angle of the line is 180 degrees. So let's go and try example 3. Grab my writing device again. Alright, so we have angle ADB and BDC are a linear pair. Alright, so we need to find each angle and we have to solve for x. Whenever you see something like this, you gotta solve for x before you find the angles, because you need something to plug in to give you the angle measure. Alright, so, oh, gotta get stretched out here. Okay, so I'm gonna draw a picture first. So I have A, D, I don't know, B. Oh, there's a BD over here. So I'm gonna draw it over to C, because they form a linear pair. So this one was 3x plus 14, 5x minus 2. Now what should these angles add up to? Like what is this whole angle from here to here? It's 180 degrees. So I just have to set up 3x plus 14 plus 5x minus 2 equals 180 degrees. So this becomes 3x plus 5x is 8x. 14 minus 2 is 12. Subtract a 12 over. 8x equals 168. And that's 21. Check me on that one. Let me know if I do something wrong the next day, because I'm doing this without a calculator. I left my notes. It's over on the table. Alright, so x is 21. So I'm almost there. Now that I know what x is, I can plug that in to one of my angles. So I'm going to plug it in over here. So do 3 times 21 plus 14. Alright? So 3 times 21 is 63 plus 14 is 77 degrees. Now to find, so that's the measure of angle ADB. Now I need to find the measure of angle BDC, right? Now I could either plug 21 in for x, or since it adds up to 180, I could do 180 minus 77 is 103 degrees. You'll get the same answer either way. Alright? Alright. Alright, here we go, last slide. Angle bisector is the same as a segment bisector, it just cuts an angle in half. Whenever you see bisector, it means cuts into 2 equal pieces. Alright? For an art ticket, when the magician cuts a lady in half, or is assist in half, is that actually bisecting that person? Yes or no, and why? Alright? Let me know tomorrow in school. Monday or Tuesday, whatever it is. I'm not coming to school tomorrow, it's a weekend. Anyway. So, an angle bisector cuts at 2 congruent angles. So, let's take a look at this last example. KM bisects JKL. And JKL 72. So I'm going to draw a quick picture here to help me out. So I have JKL. That's an L. Now I have some bisector, KM. The whole thing is 72 degrees. If the whole thing is 72 degrees, how do I find each part? Well, they're equal, right? So you can just do 72, 5 by 2. It's 36 degrees. That's the measure. Angle JKM. That's it. I hope you enjoyed. Bring your questions in the class. We'll do a few more examples in class. Arrivederci.